All right, so having defined mass, we'll define the term center of mass. We'll look at how it's found. And after we've defined some terms, we can get into the actual meat of the lecture. The term center of mass is synonymous with the term center of gravity. And this describes the point in an object that can be used to describe the object's response to external forces. Another way to think of that is that if all the mass of an object were concentrated at the object's center of mass, then that tiny object that we've now created with all of the mass concentrated, that would translate through space, it would move through space the same as the object itself would move through space. So the idea is, instead of thinking about an object in terms of having a certain size with its mass distributed throughout its volume, we can take its mass, put it all at one point, and consider it that object just to be located at that one point. And these two, if we pick the center of mass, these two objects, the large one and the point object located at the center of mass of the larger object, will act just the same. Now, here's an object. This you have to think of this as a small mass and a large mass attached to each other with this massless but infinitely stiff beam. And so when we're looking for the center of mass of the object, which consists of the two masses and the beam, what we're going to do is we're going to pick some arbitrary reference point. So in this case it's this, and we're going to measure to each of the objects, giving us the distance from this reference point to the M1 being x1, the distance from the reference point to the larger mass being x2, and if we multiply each mass by their distance to the reference point, add them together, and divide by the sum of the masses, we end up with some distance in between. This is kind of like a weighted average of where the masses exist relative to the reference point. Now, if M2 is bigger than M1, because this term gets bigger, the center of mass moves closer to M2. If M1 is bigger, then this term is bigger, and the center of mass moves closer to M1. For a solid body, the center of mass is also the balance point. So this is the point where if you put your finger under the center of mass, the object will balance. If the object's resting on a surface, there has to be a support beneath the center of mass or that object will fall. And if an object is suspended freely, the center of mass will come to rest below the point of suspension. So if you hang an object, the center of mass will always end up directly under the point where you hang it. This last property allows us a way to find a center of mass. So let's turn on the webcam and see if we can make this happen. Hello. All right. So what we said was, if we suspend an object, the center of mass ends up directly below the point of support. So here's a coat hanger and a plumb bob, which is actually a kitty necklace. If we hang this such that the plumb bob is supported at the same point as the coat hanger, we can inscribe a line there. I'll do that as best as I can. And I know that the center of mass is somewhere along that line. Let's see if I can draw that a little bit darker to make it easier to see. If I support that coat hanger then from a different point, there's a different line inscribed. I'll trace that line out too. And if I hang it from a third point, you can see they all roughly converge on one spot. The fact that they don't converge perfectly is more a testament to the hurried nature of the demo, but we can say with a decent amount of confidence that the center of gravity of this coat hanger rests somewhere in that small triangle. Now, for a rod, the center of mass is at its midpoint. This is assuming a constant composition all the way through the rod. For a sphere, at the center of the sphere. For a ring, the center of mass is at the center of the ring. The center of mass does not have to reside within the structure of the object. If you think about those balancing birds, you know what I mean? If you think of those balancing birds that sort of look like this, with the tail and the nose, and wings out here. A lot of you will have seen these in the past. This is the type of bird where if you put a ruler or your finger here, the bird will just sort of hang in space there. The reason this works is because the wings are weighted such that the center of mass is directly below the beak. And so when you put the beak on your finger, the center of mass is below a point of support and it can hang out almost indefinitely. The center of mass, you'll notice, because it's underneath the beak and because there's only empty space beneath the beak, just like the ring, the center of mass does not exist within the body of the object, it's somewhere below. And that's certainly possible, as in this example.